The next step is to create a strong baseline where we are going to use the Qwen 2.5 vision language model, the 7 billion instruct model, and see how well this model can perform with the zero-shot detection. Once we have the results, we are going to use some key techniques to improve the results and automate this invoice parsing task. To run this experiment, I'm going to use the run parts A40 GPU, which contains 48 GB of VRAM. Okay. Now let's go ahead and load the model. To load the model, the first step is to install the transformers package from the source. Let's go ahead and install this. And then while it's installing, we are going to use the Qwen utilities which are already part of transformer package. To do that, let's go ahead and install this utility as well. Okay. Good. Now the next step is to load the model and load the processor. To do that, I'm going to look into this example. Let's take this code and paste it here. Okay, great. Now we have the model. We're going to leave the touch type to data type to auto, and I have only one GPU, so let's set it to auto. And here we are loading the model, and here let's go ahead and do this. Okay, let's wait for the model to be loaded, and once the model is loaded, let's run NVIDIA SMA and see how many GB of VRAM is right. I'm going to use this prompt from Maestro book, which is set of instructions. As we see, you are a vision language model specialized in extracting information, and we have to say what are the manifests which are available, such as menu, submenu, subtotal, and total. Focus on identifying key information and provide only the output in the JSON structure. And we are going to add one more important item, which is our schema dictionary. Right. Now let's go ahead and print the prompt. Here we can see first we have a set of instructions saying like you are a vision language model expert having expertise in extracting structured information, and we have specified the schema. Okay, one other important thing is that each section will have multiple keys, and the image may not contain information for all the keys, and hence let's add one more important statement, which is fill the keys only if the information is available. This just to make sure that model is not trying to fill in all the keys and kind of have these information as empty string. Now we have the prompt ready. Let's go ahead and create the inference for one particular image and see how well it works. For inference, I'm going to use this transformers example. Let's divide it into two parts. The first one is to create a message. So create messages. And we are going to create this message. Okay. Now this messages takes two inputs. One is the image URL. Instead of URL, we are going to use the image local path, and the prompt, the instruction to the model, which we created in the previous step. So let's have image path and the prompt as inputs, right? And once the message is created, let's say messages, and here we go. The next step is to take this message, apply the chat template, use the processor and convert this text inputs into IDs, and then pass this input IDs to the model and generate the output tokens. 128 might not be enough because there might be cases where the invoices has multiple line items. In those cases, we might need more tokens, and the last set of code generates the tokens and then decodes the output tokens and prints them. Let's create this as another method, define inference. Okay, let's say infer, and then it's going to take the messages or the model, the Qwen 7 billion model, and the corresponding processor as it, right? And we are not only going to print the text, and we are going to return the output text as well. Let's run this. We are good to go. Now we have two methods which we can use as utilities to run the inference for all our dataset images. Let's go ahead and iterate the dataset. For row in dataset of test, we're going to perform the baseline only for test. Let's add tqdm so that it shows the progress. From tqdm, import tqdm. Okay, now let's print the row and then break for now. Okay, so now we have the image in the ground truth. Let's save it to the respective variable. Image is going to be row of image. Okay, and as we know, this is going to be PIL image, and let's save this to a folder for OS. If os.path.exists of test, I'm going to save it in test folder. If not, negate this condition, then os.mkdir of tests. Okay, now we have the test folder. Let's do image.save of os.path.join. Okay, we're going to save it in the test folder, and unfortunately this data doesn't provide an ID, so let's use the index I plus 1 equal to 1. Now test underscore I.png. The next step is to gather the ground truth, right? The ground truth is row of ground truth here, and as we know, we are not interested in the entire ground truth, so we can do is json.loads of this, and then you take only the gt parse segment, which is the actual ground truth information, right? Let's just print this ground truth to make sure that the parsing has been done without any errors for the first image. Okay, here we go. Now we have inside this test folder, we have the test0.png, and we have this ground truth information. Now let's go ahead and pass this, create the message using the create messages. So the messages is going to be create messages of, here we have this create messages, which takes the local image path and the prompt, right? So let's have this image path equals this, and image path, and pass in the image path here, and we have already defined the prompt, so this should be our messages, right? Here we can see this is our image, which is the local path, and we have a prompt along with the schema which has been, right? And now the next step is to use the infer module. Okay, so the output, or we can call it as prediction, is nothing but the infer of infer takes 3 arguments: messages, model, and the processor. Messages, model, processor. Okay, now let's print the prediction. It took around 9 seconds to process this image, and we have the output in the JSON format, right? To capture this output, let's create a list. Let's call it prediction list. And for comparing this against the ground truth information, let's also have ground truth list. And whenever we parse this ground truth, let's do ground truth list dot append of ground truth information for that particular image. And then once we have the prediction information, let's do prediction list dot append of prediction, right? And now I'm not going to run this for only one image. I'm just going to remove this break statement, and it's going to run it for entire test data set, which is going to be 100 images. Once all the 100 images are processed, we will have the information in this list, which we can compare in the next step. Okay, let's go ahead and run it. As we have seen, each image takes 9 seconds. Let's wait for this to get completed. It took 17 minutes to process these 100 images. There are two important points to note here. If you are running with the image which is huge in size, there may be a case where you will end up with code out of memory. If you really want to avoid that, you can add these two parameters, which is a resized height and width, which basically resizes your image into 640 into 640 dimension. Now we are running with constrained GPUs, and hence I have done this processing in a sequential manner, which is relatively slow because each image takes around 10 to 12 seconds to process. However, if you have enough GPU memory, consider adding a batch prediction here. Now for the next step, let's go ahead and print the prediction. Let's take a sample prediction, which is prediction list of 0. As you can see, it contains a list, and hence let's do of 0 again. Okay, it's in a string format and it contains backtick JSON. Let's do a replace backtick JSON by empty string, and there is a series of backticks at the end as well. Let's replace that with an empty string. Okay, here we go. Now it's in string format. Let's do a JSON that loads to load it in the dictionary form. Now we have to do it for all 100 items, and the basic assumption is that model is going to return everything in a proper JSON structure. So I'm going to write a method called postProcess, which takes in a text. This is going to be each prediction, and let's say parse the text is empty, right? And then let's say try, because we are not sure whether the JSON loads is going to give us an error or not. Parse text equals, let's take this and paste it here, and instead of prediction list of 0, it's going to be text. And if it is successful, we are going to return it. If it is going to be a failure, let's add a f string, unable to parse text, prediction text. Let's attach the text here as well. Okay, and if we are able to successfully parse it, let's return the parse text. Okay, we have the post process method here. Let's try to run it for prediction list of 0. Here you go. So it has converted the prediction list into dictionary format. Now let's write list comprehension x. Okay, post process of x for x in prediction list. So we are going to iterate through the prediction list, all 100, pass it to the post process, remove the backticks, load it as a JSON, load it as a dictionary, and return it back, right? So the prediction list is going to be updated list of elements in list of dictionaries section. If we have if the model has written all these text in a proper JSON format, we should not be getting any error in this step. Here we go. We didn't receive any error, and the prediction list. Now we have the dictionary with the predicted elements, right? And let's also do the ground truth of 0. Okay, ground truth list of 0, and which is again a dictionary. As we can see here, there is a this is our ground truth and this is the prediction. Even though the values for example, the name and the number and the count are accurate, we have relatively lesser keys when we compare the prediction and the ground truth. In the prediction, the model is trying to substitute empty strings whenever there are no values. In such cases, we can add an example to our prompt to make sure that model does not return the empty string. Okay, we have the results. Before we go ahead and update our code with few short examples, it is important for us to baseline and understand how well the model has performed. We cannot compare each and every images one by one, which is going to be time consuming. And hence we are going to write some evaluation code, which is going to decide how much percentage of items are matching between the ground truth and the predicted text.